Okay, so today I'd like to talk about expanding and simplifying logarithms. But I can't talk about logarithms without actually talking about exponents because logarithms are simply the inverses of exponents, and therefore all of the rules that apply to exponents also apply to logarithms. We want to start off with the two basic rules that we have, both the product rule and the quotient rule, of defining what happens when we have when we multiply two values that have the same base, and what happens when we divide two things with the same base. So I start off with two examples here. My first example is x squared times x to the third, and you need to remember that this is going to end up giving me x to the fifth power is what's going to happen here. I'm going to go ahead and add those. If you needed a reminder of where that actually comes from, this x squared here, this first x squared, would give me 2x's, so that would give me x times x right there. I could put that in parentheses. And then the second one would give me 3x's. 1, 2, 3. And so if you expanded everything, you could see that you would end up having a total of 5x's right there. So we're going to, when we multiply, we actually end up adding. Likewise, when we divide, you actually end up subtracting is what happens. And if you forget about that rule, of course, you can just use what the definition of an exponent is. This is I have to write this y 6 times. There's going to be 6 of them here. Let's see if I can get them all to fit. There's 6 of them there, and I have 4 of them in the denominator. And so you'll notice here is that I can start canceling these off. Cancel, 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 and cancel. And you'll see that I have 2 of them left over. And so the shortcut that we take is y to the 6th divided by y to the 4th is going to give me y to the second power. Okay, so what I would like to do is I'd like to use those two properties of exponents that we have, both the product rule and the quotient rule, and extend those into logarithms. What I have here is I have the log of 2x. This has been simplified. It's cleaned up as much as we possibly can. And if I were to be asked to expand this, I could rewrite this actually as a sum. The sum that I would write would be the log of 2 plus the log of x. And you'll notice these values on the inside here were broken up as the log of 2 plus the log of x. We can go both directions. We can be asked to expand, which means that we go in that direction, which makes it larger or longer, if you will. And if I go the other direction, that would be considered a simplify. The next example I want to talk about is the log of 2 divided by x. You'll notice on the inside here that I actually have a quotient or division, and therefore when I separate these or I expand this, this is actually going to turn into a difference. I'm going to have the log of 2 minus the log of x. You'll notice these things here on the inside. That quotient here has been split into 2 separate pieces, but because we were dividing, we actually have to subtract the logarithms. The last idea or topic that I'd like to talk about is how you actually handle an exponent. So in this situation, you'll notice that I have a log of x squared, but really a log of x squared could be written as the log of x times x. In other words, this actually ends up becoming a product. If you have a product, just like we talked about with our first example, we can write the product as a sum. In other words, the log of x times the log of x becomes the log of x plus the log of x. If I add those two together, so you will notice that now I actually have 2 logs of x. And so what we can do is we can actually travel from this first one all the way to the last one. An exponent can simply be brought out in front because exponents really is repeated multiplication, and repeated multiplication can actually cause us to simply add. So we ended up with 2 log of x. Okay, so to tie this all together now, I have a logarithm here that's quite complicated, and what I want to do is I want to expand this as much as I possibly can. You will notice that I have a product on the top of 3a squared b, and that is all being divided by c cubed. And so this expansion is going to make things quite long, but I'm going to go ahead and break this up into pieces for you to see how this works. So I'm going to start with the log of 3, and I can add that to the log of a squared, and I can add that to the log of b, and lastly I'm going to subtract the log of c to the third. I am not finished yet. There is one more step. And so the log of 3 can just be written down. I'm going to go give myself a line here. The log of 3 can be written down, and nothing can happen to that. But what happens here with the log of a squared is that the 2 can come out front. And so I'm going to have the 2 log of a is my middle there. My b is just going to be simply added the log of b. So I can go ahead and put that one there, finish that up there. And the last one is this minus here. That's c cubed. The 3 can come out in front of that, and I end up with the log of c. I'll go ahead and put that c in there. So hopefully this has explained with you how to both expand and simplify logarithms.